friends, today I'm going to discuss about satellites, construction, type, launch orbit, countries capable of building, in life, importance and uses. What is a satellite? Satellite is a moon, planet or machine that orbits a planet or star. There are two kinds of satellites, natural such as moon orbits the earth or earth orbits the sun, and artificial such as International Space Station orbiting the Earth. Artificial satellites, however, did not become a reality until the mid-20th century. The first artificial satellite was Sputnik 1, a Russian beach ball-sized space probe that lifted off on October 4, 1957. That act shocked much of the Western world, as it was believed the Soviets did not have the capability to send satellites into space. Following that feat, on November 3, 1957, the Soviets launched an even more massive satellite, Sputnik 2, which carried a dog, Laika. The United States' first satellite was Explorer 1 on January 31, 1958. The satellite was only 2% of the mass of Sputnik 2, however, at 30 pounds, 13 kg. The main instrument aboard was a sensor that measured high energy particles in space called cosmic rays. Since Sputnik 1, about 8,900 satellites from more than 40 countries have been launched. According to 2018 estimate, 5,000 remain in orbit. Of those, about 900 were operational, while the rest have lived out their useful lives and became space debris. Approximately 63% of operational satellites are in low Earth orbit, 6% are in medium Earth orbit, 29% are in geostationary orbit, and remaining 2% are in elliptic orbit. Construction. Satellites come in many shapes and sizes, satellites mainly having the following parts. Antenna. Satellite antenna systems are used to receive and transmit signals to and from Earth. Power source. Most satellites rely on solar array to convert sunlight into energy. Command and control systems. The operational heart of satellite command and control systems monitor every aspect of the satellite and receive commands from the Earth for operation. Guidance and stabilization sensors. Sensors monitor the satellite's position to ensure it remains in correct orbit and is oriented towards the correct target. If necessary, thrusters and other maneuvers allow a satellite to fine-tune its position and orientation. Thrusters. Through these satellite positions are adjusted for orientation, altitude control. Science instrument. A satellite carries instrument to obtain data on magnetic fields, space radiation, Earth and its atmosphere, the sun or other stars, planets and their moon, and other astronomical objects and phenomena. Container. Constructed from strong material that can withstand the harsh space environment. Thermal control. Guards satellite equipment against extreme changes in atmosphere, against extreme changes in temperature. Transponders. Uplink and downlink signals arrive and depart at different frequencies. Transponders convert uplink frequency to downlink frequencies and then amplify the converted transmission for sending to Earth. Types of satellite. Satellites are of various types. Some of them are weather satellites, used to monitor Earth's weather and climate. Navigation satellites uses radio time signals transmitted to enable mobile receivers on the ground to determine their exact location. Earth observation satellites used for non-military uses such as environmental monitoring, meteorology, map making, etc. Communication satellites used for the purpose of telecommunications. Astronomical satellites used for observation of distant planets, galaxies and other outer space objects. Biosatellites designed to carry living organisms, generally for scientific experimentation. Launch orbits. Based on altitude, mainly four types of orbits are used, which are low Earth orbit, medium Earth orbit, geostationary orbit, high Earth orbit. Low Earth orbit is any orbit below 2000 km. Medium Earth orbit is any orbit between 2000 to 35,786 km. Geostationary orbit works at 35,786 km. And high Earth orbit is any orbit higher than 35,786 km. Countries capable of building plus launch satellites indigenously. The list does not include the European Space Agency and multinational state organization. The first one in the list are Soviet Union, the United States, France, Japan, China, United Kingdom, India, Israel, Russia, Ukraine, Iran, North Korea, South Korea, New Zealand. Countries are serially arranged based on their first launch. End life of satellites. When satellites reach the end of their mission, normally occurs within 3 to 4 years after launch, satellite operators have the option to deorbiting the satellite, leaving the satellite in its current orbit, or moving the satellite to a graveyard orbit. Historically, due to budgetary constraints at the beginning of satellite mission, satellites were rarely designed to be deorbited. One example of this practice is the satellite Vanguard 1 launched in 1958. Vanguard 1 was the fourth artificial satellite put in geocentric orbit, was still in orbit as of March 2015, as well as the upper stage of its launch rocket. Collision between satellites possible. Actually they can. United States Space Surveillance Network keep an eye on orbital debris from the ground and alert NASA and other entities if an errant piece is in danger of hitting something vital. This means that from time to time ISS needs to perform evasive maneuvers to get out of the way. In February 2009, two communication satellites, one American and one Russian, collided in space. This, however, is believed to be the first time two man-made satellites have collided accidentally. Importance and uses. The bird's eye view that satellites have allows them to see large areas of Earth at a time, which means satellites can collect more data more quickly. Satellites also can see into space better than telescopes at Earth's surface. That's because satellites fly above the cloud dust and molecules in the atmosphere that can block the view from ground level. Before satellites, TV signals did not go very far. TV signals only travel in straight lines, so they would quickly trail off into space instead of following Earth's curve. Sometimes mountains, tall buildings would block them. Phone calls to faraway places were also a problem. Setting up telephone wires over long distances and underwater is difficult and costs a lot. With satellites, TV signals and phone calls are sent upwards to a satellite. Then almost instantly, satellite can send them back down to different locations on Earth. Satellites are used for scientific research and for other purposes such as communications, weather forecasting, navigation and global positioning, Earth resources management and military intelligence. Examples of manned satellites include space stations, space shuttle orbiters and Apollo spacecraft in orbit around the Moon or Earth. Thank you.